Which vertex in the polygon constraints maximizes Avery and Michaela's profits? 1575. How many of each type of smoothie should Avery and Michaela produce? Well, she should produce 15 blueberry smoothies and 75 chocolate smoothies in order to maximize her profits. And that's it for question number 1. Have a good day. Question number 2, a polygon of constraints is shown in the graph below. The rule of the optimizing function is c is equal to 6x plus 5y, and the objective is to maximize. A, identify the system of inequalities whose solution set is represented graphically. So I'm going to start with this point. I got my b is equal to 20. My slope is I'm moving 1 over and 1 down. Or like we're going from that point to, I guess, the b value down here. We're moving over 20 and down 20. The delta x is 20, the delta y is negative 20. Negative 20 over 20 is negative 1. We have a slope of negative 1. Y is equal to negative x plus 20. We are shading below. It's a solid line, so y is less than or equal to negative x plus 20. For the next one, my b value is 13. My slope is, I'm moving over 2 and down 8. 1, 2, 3, 4, 5, 6, 7, 8. My delta x is 2, my delta y is 8, or negative 8. Negative 8 over 2 is negative 4. My slope is negative 4. We're moving over 1 and down 4. Over 1 and down 4. There you go. Y is equal to negative 4x plus 13. Because we are a dotted line, it is going to be either greater than or less than. And because we're shading above it, it's greater than. Y is greater than negative 4x plus 13. This dotted line here, it's going through the origin, so it doesn't have a b value. Its slope is it's moving over 2 and up 5. So it's 5 over 2. So y is equal to 5 over 2x. Because it's dotted, it's going to be greater than or less than. Because we're shading below, it's going to be less than. Y is less than 5 over 2x is this dotted line here. Finally, this line, the slope is we're moving over 3 and up 1. 1/3 is our slope. Our b value is 0. Y is equal to 1/3 x. Because we are shading above this, it's going to be greater than or equal to. Y is greater than or equal to 1/3 x. Find the point or points whose coordinates generate the function's optimal value. I need to figure out all of these vertices, each vertex. This one here, can't read it off the graph, so I'm going to have to calculate it. We have y is equal to 5 over 2x, where it meets y is equal to negative x plus 20. I set up my system of equations. I want to get rid of this 2, so I'm going to multiply each term by 2. That's going to give me 5x is equal to negative 2x plus 40. I'm going to add 2x to both sides to get rid of this negative 2x, and that gives me 7x is equal to 40. Divide both sides by 7, and that gives me 40 divided by 7 is 5.714285, and it goes on forever. 5.7143, we can round it. The y value is going to be, I can just feed it into this equation or into that one. I think this one's a little easier. Y is equal to negative 5.7143 plus 20, and that gives us y is equal to 14.2857. That is going to be our x and y value at this point. Our a point is going to be 5.7143, comma 14.2857. The b value, we can read it right off the graph, is going to be 15.5, and the c value is going to be 3.1, and the d value is going to be 2.5. If I was going to do the scanning line, I'm going to put the c on the opposite side. So I have 5y plus 6x is equal to c. Subtract 6x from both sides, and that gives us 5y equals negative 6x plus c. I want to get rid of this 5, so I'm going to divide every term by 5, and that's going to give me y is equal to negative 6 over 5x plus c over 5, which I'm just going to call it my new b value. We're going to have many b values. It's going to move up and down, so we don't really care what the b value is. Y is equal to negative 6 over 5, and if I pick a b of, let's say, 22, start at 22, move over 5, 1, 2, 3, 4, 5, and then down 6. 1, 2, 3, 4, 5, 6. It's going to go through the 22 and through this point right here. Our scanning line is going to look something like this. If we bring it down here and it'll go through the A, it'll go through the polygon, which we don't want. So we know that won't be our maximum. But notice it goes right through the B. It would go also through the C. So we know the B is our maximum and C is our minimum, or C is our maximum and B is our minimum. We're not entirely sure. We're going to have to work those two out. The scanning line would save us figuring out vertex A and vertex D. Here's all my vertices. The profit formula is 6 times the x value plus 5 times the y value. For A, we're going to get $105.71. For B, and we want to maximize this, right? We're going to get 15 times 6 plus 5 times 5 gives us $115. For C, we get $23. And for D, which is our minimum as predicted, and for E, we get $37. B is our maximum, and C is our minimum. We want to maximize this, so we would use B. find the point or points whose coordinates generate the function's optimal value is B, and the optimal value is $115. And that's it for question number 2. Have a good day.